Hey everybody, this is Larry. This is me going Q3 of the bi-weekly contest 137. Maximum value sum by placing 3 rooks 1. 3 rooks 1. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. So this one's definitely very tricky. My initial thought on this one was dynamic programming immediately. The number of rows is 100, the number of columns is 100. So I thought maybe it'll be good enough, but it turns out that that's not enough, right? Because if you just do a naive recursive problem where you have, you keep track of the last 2 rooks, well, that's going to be n squared or something like this, plus the c squared times r, and then you do another C, it's going to be too slow, right? So you have to make one optimization. And the optimization to realize is that for each row, you do not need you don't need the entire row. You only need up to 3 items per row, right? Because, yeah, and I actually use 4 in my constants. This actually reminds me of the problem that we had on the daily problem, or this part of it anyway, is because that, for example, if given in a row, you use the 4th most, like you never use the 4th most value because it doesn't matter because you can only block 2, you can only block 2 columns from the previous rows, so you can always use the 3rd column, right? So you only need the 3 max columns inside for every row, and given that, that's really all I needed to let me give us a quick submit. That's all I needed to do the dynamic programming. Why is it so slow? Yeah, that's all I needed to do the dynamic programming, is keeping track that for each row we get rid of any extra data except for 3 of them. And what happens when that happens? Well, now instead of having 100 columns, you only have 3 columns, right? So then we could go over the code real quick. So I wrote this in I'm not gonna lie, the code is very awkward, a little bit not clean, but we're going over it now. And basically I construct a new board, and as I said, for each row, we are going to append a list with, you could probably also use like a heap n largest or something like this, but the way that I did is I sort this by the value, right, and the index. So the index is the column in this case, right, because it's for a given row. You have yeah. So you have the value and then the index, and you only care about the last 3 or the 3 biggest items. And that's basically my new board, right? Okay, what do we do with this? Well, this is my very rudimentary dynamic program or memorization, dynamic program memorization. Row is just the current row, pretty straightforward, can go from 0 to 100. Count is just how many things how many rooks we've placed, right? So that's just 0 to 2. Well, I guess 0 to 3, but on 3 we always return 0 because we're done. So, but yeah, C1 is the first rook we placed, the column of the first rook we placed. C2 is the column of second rook we placed. So that's basically the idea. And here it goes 0 to 100 and 0 to 100. And of course, in this particular case, to figure out the time complexity, so total time is going to be equal to the total or number of inputs times time per input, and the number of inputs is just equal to, well, here, right? So we have I want to say, okay, I kind of just put count up here because it makes it easy to do this if statement a little bit easier, but keeping in mind that this count offers no additional information because C1 and C2, I actually lied about this 0. I also do -1. -1 is unused, right? So we haven't placed it yet. So that's basically the idea. So this doesn't actually add more states because this information is already conveyed in here. So the number of inputs is just 100 times 100 times 100. Technically, I guess this is like 101. This is 102, but roughly the same. So this is going to be about a million, right? Each input takes, well, now, so if we did not make this optimization about taking the 3 highest value, then each input would take O of C, right? The number of columns. So then that makes it 100 million. But well, maybe also but with optimization, each input takes O of 3, which is O of 1. So now it takes about 3 million, right? I mean, it's roughly, but you know, so that's basically the idea. So now it's going to be fast enough, and that's basically what we do. And the rest of this is just a very easy tick, no tick, right? I always say, you know, and I'm not gonna lie, I'm very sad about this part because I got a one wrong answer because I forgot to do the no tick. So this is the no tick, right? You can even put it up here, right? This is no tick. Skip this row and go to the next, right? And then tick one item from this row, right? That's basically the idea. And here this is just going through the iterations. Basically, if the current index is not unused, it's not used before, so if index is not equal to C1 and it's not equal to C2, then here we just throw out one of these, which is if C1's not used. You could also do if count is equal to 0 or something like this to kind of fill it out, but it's the same thing, right? Conveys the same information. So yeah, so if C1's unused, then we just put index there. If C2 is unused, we put the index there. C1 we leave unchanged, and then else we leave C1 and C2 because it doesn't actually matter. I guess we don't even need, because this just returns 0, so we don't even need to do this. We can just say because that's just going to return 0, so we can actually do this. So maybe that's a little bit oh, I guess we don't need this best anymore because I moved it up, that's why. Yeah, so this is slightly faster, but I mean, you know, it's not a big deal. And that's pretty much it, right? So that's the idea about this function, and this is the big optimization. You can write this in much cleaner way. You should be able to do this part in linear, but I'm not going to worry about it because it's not it's not that expensive. So I didn't worry about it because it's just 100 elements. 100 log 100 is pretty fast. I don't need to save the log 100 times for this part. So yeah, so what's the total complexity? So this is going to be dominated by this. There are some stuff here, like we said, but it's still dominated by this, which is going to be, the 3 min is to say that it is fast enough, but the actual complexity is going to be R times C, right? So that's the time and space. And yeah, and that's all I have for this one. Let me know what you think. Thanks for watching. And you could watch me solve it live during the contest with the silly mistake next. This on Q1 first. Okay, so then here we should be good, right? All right. Whew. Okay, we're Gucci so far, maybe? I don't know. Let's see, are they the same problem? They're the same problem except for it's 500 instead of 100. Okay, let's solve this one first anyway. Well, read the problem first. No one's gotten cute. Okay. You need to place 3 rooks on. Oh, okay. So 100. It shouldn't be that bad, but at least for the easier version. 100, 100, 100, right? That's it. Whoa. I want to maximize. Is this too slow? 100, 100, 100. No, I guess this is too slow. Okay, how do I optimize this? Okay, so you do. Do the columns matter more or the rows matter more? I guess they both matter a little bit. Yeah, no, this is not right. I thought maybe I could, but someone got it already though, the 500 version. I don't even know how to do the 100 version, honestly. So pick a column, go to the next row. Well, they could be base case, I suppose. Because then now you remove so then now you get the max 3 items from each thing. Yeah, okay, fine. I think this works, but it's a little bit clunky. Okay. Okay, so we should be able to reduce. Maybe, okay, think about that in a second, but let's no, we don't need that. So then now for each row, you want to get the 3 max items, right? could even do better than that, but I don't think you need to. In fact, we could do this entire thing anyway. So then now we just max 3. Okay, actually let's do it that way then. Okay. How people doing anyway? Yeah, okay. Doesn't matter, focus. Okay, so then now let's say we have a list of this, and then now we just take the last 3 items. Right. Okay, let's double check that this is what we want. Okay, this is good. The other one's not so good, really. Oh, it's from 0 to the -3, but it should be -3 to 0. Okay. Okay, this is what we want. 1, 1, 2, 1. Second row is going to be -1. Okay. What happens on tie? Tie, I guess, don't matter that much. Does it? Do ties matter? Maybe, maybe not. I don't know. We can do -4 just in case. Shouldn't affect these things. And then now we can do this one row at a time of tick, no tick, right? Okay. So then now we go for, okay, yeah, now this should work. 12 people's gotten it. Yeah, okay, so then now we could even optimize this a little bit more, but I don't think you would need to. So okay. Okay, so so take one from this row. So then for X index in new board of row, we want to say if we'll just do a count, I suppose. Doesn't really matter, I think. It doesn't change the thing. Makes it a little bit more complicated, but not really. Okay, then if count is equal to 3, then we return 0. Then we return -infinity. Okay, so then now it's a little bit awkward for sure. Okay, so then now we have best is equal to -infinity. We return best. And then now, I'm worried that this is going to still be a little bit too tight, but it should be okay. So then if index is not equal to 2, then we have, yeah, if C1 is equal to -1, then best is equal to min or max best row +1, count +1. This is the new C1. So that C2 is going to be -1, hopefully. Plus the cost, which is X. Okay, that was if C2 is equal to -1. Then you do the same thing. Just type it out, fine. You type fast anyway. C1 index plus X. And then else else best is equal to max best. Go roll +1, count +1. It shouldn't matter because count should be already 3. So okay, let's see, 4, 15, 3. Alright, is it fast enough? YOLO. It's not even right enough. Why is this not right enough? Do we only not, well, I was gonna say that we only care about 4, but we don't even eliminate 4 of these. Why is this wrong? Huh? So I'm doing a very suboptimal answer. Oh, I don't do the no tech. I forgot the no tech. Okay, fine. I knew that yeah, okay. I forgot to do the no tech, silly Larry. Okay, YOLO submit. Hopefully it doesn't time out. That's the only thing I worry about. How did I forget the no tech? Okay, so that's good. Silly mistake. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this farm, this contest, this video, everything in between. Come to Discord. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye-bye.